Good evening, everybody. Coming at you tonight with a system of equations that involve logarithms. Now, I'm going to write down a property that I don't think anybody would doubt would be useful to solve a problem like this. Log base 3 of 3 raised to, we'll call it r is any real number, is equal to r. That's literally the half of the defining property of a function and its inverse. You could also write this as 3 raised to the log base 3 of r is equal to r. Is the other way around, like f of g of x, g of f of x kind of thing. All right, but anyway, there's no doubt that this is going to be a useful property because look at this 9 here. I mean, this 9's in the denominator. We have a base of 3 here, and so you're expecting this to come in quite handy. Now, I will say another approach is just due to the standard difference thing. You could write this as log base 3 of m over n, get a relationship, and solve it from here. I'm going to try to do it slightly differently, or differently, I guess. Okay, now, so notice that we can rewrite this as 2187 over 9. And hopefully the motivation is fairly self-evident here. Okay, now, so this part right here, just this little piece right here is equal to 1 over 3 squared, right? Okay, or you can call it 3 to the minus 2. This is bad the way I'm writing it. But just this piece right here is equal to 3 to the minus 2, okay, which might help you to see how this minus sign is going to get offset. Now, also, you would anticipate since m and n are given to be integers, you're expecting 2187 to be a power of 3 itself, okay? And indeed, if you spend just a little bit of time with this, this would be equal to, what is that, 3 to the 7th over 3 squared. And over here, folks, this part right here is plus 3 to the minus 2, right? Now again, folks, it takes a little bit of time to confirm that 3 to the 7th is 2187, but it's 3 to the 5th is 243. 3 times 243 is what, 729, and if you multiply 3 times 729, you get this, okay? Now, so what do we got? Well, this would be 3 to the 5th plus 3 to the minus 2. Okay, and we can choose this one to be m. And it is important that this one is m, by the way, and this one to be n, right? Because you see, if you get a solution right here, in other words, these two check. Okay, don't make me plug it in, but it checks right here, doesn't it? Okay, if you take, sorry, do we got it on the screen? Yeah. If you take this one to be m and this one to be n, what you would get right here would be, let me just write this up here to the right. You would get 5 minus a negative 2, right, folks? Again, we're using this property again, log base 3 of 3 to the r is equal to r. We used it twice to get 5 and negative 2 respectively. 5 minus negative 2 is 7. So this is the solution, folks. 3 to the 5th. Well, sorry, let me just write it. M equals to 3 to the 5th. Y'all, which is, what is that, 243? 243. And n is equal to 1 over 3 squared. Which is equal to 1/9. So those are our two solutions. I think they're unique. I know that these kind of things sometimes have complex solutions. That's why I nailed it down to just be integers. So this is m and this is n. Alrighty, that's all.